Hi, my name is Genevieve Budlery, and I am a technical marketing engineer with Dell Technologies. Today, I'm joined with Steen Graham, the CEO of Metrum AI. We're thrilled to showcase a new solution revolutionizing the telco industry and landscape. Steen, can you tell me a little bit about the vision of this use case?
Yeah, Genevieve, thanks for having me here and building some incredible compute-intensive solutions. One of the things that I wanted to talk about a little bit is the challenges that telecommunications providers are facing right now. Just next year alone, they're going to have exaflops of data on their network driven by tens of billions of machine and human-based devices. And that explosion of data is putting really major challenges on telecommunications infrastructure.
Yeah, so there's a clear need for this in the industry. So can you talk to me a little bit about the solution that we came up with?
Yeah, absolutely. So one of the things that we wanted to do is we wanted to use modern generative AI techniques to monitor the telecommunications infrastructure. And so if you look at a base station, there's a couple of critical components, the baseband units and the radio heads. And so what we're doing in this particular solution is we're monitoring that particular infrastructure. And we actually take the telemetry data from that infrastructure via the Kafka protocol. And that protocol is monitored by autonomous AI agents. And that's essentially an agentic RAG approach. So we have a full retrieval augmented generation background that's pulling all that telemetry data into an autonomous agent that's monitoring that infrastructure. And as it's monitoring the infrastructure, it's looking for a couple of critical components. One, it's looking for things like, how's my quality of service? So we're looking at data drop rates and we're looking at call drop rates. Critical, nobody wants their calls to be dropped. Nobody wants their data plan to not be accessed, especially if you're trying to get a reservation for dinner or critical activity upcoming. And then we're looking for total communications link failures and downtime as well. And so what's great about these autonomous agents is they can monitor this where traditionally a human would have to monitor this based on a dashboard. These autonomous agents are independently monitoring all of that infrastructure. And even cooler is they can actually do root cause analysis when you have an issue like a communications link failure. You can just push a button and it'll go back into a knowledge bank of prior reported issues, understand how we previously resolved these issues as well, and suggest resolution steps.
Awesome. The process of incident reporting on this system, can you tell me a little bit about that?
Yeah, that's a really critical element. So when you talk about incident reporting, first, the autonomous agent identifies if we're not meeting a quality of service metric. And if you can look at that, we illustrate on the base station, if it turns green or red, you can see that base station's underperforming on quality of service, or it has a communications link failure, all the other characteristics that'll have problems. And then the next step would be to actually click on that, and then you'll get a knowledge bank of how to, a suggested communications resolution issue, or how are we going to fix this comms link issue from the baseband unit to the radio head. And then we can even push a button and it'll generate a root cause analysis report. Wow. Subsequent to the root cause analysis report, we can also say, hey, we like this root cause analysis. AI did a good job, or not. We can edit it and look at other resolution items. But if we like what it's done, we can create an incident report and even issue a work order. So now that we can have a professional come and fix that base station based on that particular issue, could be a communications link failure, for example.
And what's amazing is that all of this processing is happening in real time. And this is powered by the Dell XE9680 with 8 AMD Instinct MI300X accelerators. This has a massive memory footprint, with each accelerator holding 192 gigabytes of memory. So this is a crucial piece of hardware for this solution and makes possible for us to implement this RAG solution.
Yeah, absolutely. And what we're able to do with that large memory footprint is we're able to run this full agentic RAG solution. So the embeddings model, the vector databases, the autonomous agent, the language model, all of that can run, and we can support monitoring, multiple concurrent base stations, baseband units, radio heads, with that massive memory footprint and infrastructure. So the capability is just unparalleled with the MI300X accelerator on the flagship XE9680.
Thank you, Steen, for joining us on this incredibly innovative solution. If anyone wants to know a little bit more about the Dell XE9680 or the MI300X Instinct accelerators, please visit Dell.com.